Hello, welcome to the next topic of comes under electric field. Okay, in the last sessions we have learned about last topics we have learned about what is called electric field intensity and the vector form of electric field intensity and the superposition of electric field intensity. Three topics we have learned. Okay, we are moving to the fourth topic and write down the heading: equilibrium position of electric field intensity. Equilibrium position. Write on the heading: equilibrium position of electric field intensity. Equilibrium position of electric field intensity. Hope you have remember we have learned about equilibrium of a third charge which we are going to place in between or away from the lowest charge. We have learned on concept of equilibrium in Coulomb's law. The same concepts we are going to apply will be here also. That is, there are no differences. We will just recollect what we have learned in Coulomb's law, then we will come to electric field intensity, so that it is very easy for us to connect between these two. So let's first recollect. We have learned in case of equilibrium points, we have learned two concepts we have learned in Coulomb's law. So this is basically I am representing for Coulomb's law. Okay, this is for Coulomb's law concept what we have learned. We know if we have two positive charges are placed. Okay, as an example I am taking plus q and plus 9q. If these are the two positive charges are placed, then where will be the equilibrium point or equilibrium positions for the third charges? This is one case. Similarly, if we have taken plus q and minus 9q, this we have learned under a topic of similar charges. So when two similar charges are there, and here it is dissimilar charges. So we have similar charges and we have dissimilar charges. When we have similar charges will be there, where I have to place the third charge, so that the third charge will come to equilibrium. In case of dissimilar charges, means one is positive and another is one is negative, where I have to place the third charge so that it will be in equilibrium. What is the concept of equilibrium? The total force on that charge will be equal to 0. So to happen that, the total force means one force towards right and another force towards left, which means two forces should act in opposite direction. So in this case, if we are placing one charge will be here, one plus q, another plus q charge will be placed will be here. What are the forces will be acting? This plus q on this plus q will act a repulsive force, and this plus 9q on this plus q will act a repulsive force. So in case of a similar charges, the third charge must be placed in between the lowest charge and the highest charge, and the distance from the lowest charge is x. This value of x we already find out in the first topic. What is the value of x? You remember, q low root of q low divided by root of q high plus root of q low, and this is multiplied with L. L is the distance between the two charges. L can also, we can mark it like this. In case of a dissimilar charges, where the positions will come? Here this is in between the charges, the x definitely in between. In case of a dissimilar charges, in Coulomb's law part 2 or part 3 video I have mentioned that if it is a dissimilar charges, then the third charge q must be placed on the left side at a distance of x meter. What is the value of this x in this case? X will be equal to root of q low divided by root of q high minus root of q low multiplied with the distance between the two charges, which is called L. Why the third charge is placed left of the lower charge? because if it is plus q, this plus q will repel with a force and this minus q will attract with a force. So here in the left side we have a chance both forces are equal and opposite, so that these positions will be in equilibrium. Here x means towards left if both are opposite sign. If both are equal sign, so definitely the third charge should be in between the lowest and the highest charge. The distance of x from the lowest charge is given, will be here for similar charges. For dissimilar charges, these equations will be given. Okay, the same case we are going to adapt it for electric field intensity. Now the same method I am going to apply for the same concept, but I am writing this is for electric field. This is for electric field. In case of electric field, what is the difference, or this will be the same? This will also will be the same. We'll take this first case, similar charges, then we'll move to the next case for dissimilar charges. We'll take the similar charges. So the first one is similar charges. First case is similar charges. In case of similar charges, we'll take the same example will be here, which means plus q and plus 9q. So the electric field intensity we are finding with respect to a position. Now here also we have three positions will be there, left and in between the two charges and the right side positions. Here I told the equilibrium position is always in between the two charges. Same case also here it is applicable. When a total electric field will comes to an equilibrium position of an electric field means electric field will be equal to 0. Equilibrium position of Coulomb law, Coulomb's force is total force will be equal to 0. Here electric field will be equal to 0. Here F net will be equal to 0. Here I can say E net will be equal to 0. Okay, so now we will take the middle position, then we will move to left and right. So if it is in middle position, if this position, as I told before, the electric field intensity field lines are away from the charges. So because of plus q, one electric field will be right side. Because of 9q, always electric fields are away from the charges. So because of 9q, it is towards left. So E1 and E2. So similar to here there are two forces, one force towards right, another force towards left, which means there is a possibility of total force will be equal to 0 because one force minus another force, both forces are in opposite direction. So F net will be equal to 0, which means the total force is equal to 0. So here also the total electric field intensity E net will be equal to 0 because E1 minus E2 both forces are equal, means electric field will be equal to 0, which means this is an equilibrium of electric field intensity position, equilibrium position. Now suppose if you are taking the left side, if you are taking left side, plus q will create an electric field. Which side? Towards left. Okay, plus 9q will also create an electric field. Electric fields are always away, going top, going left, going right, going bottom. So this is also going left. So two electric fields will be here, E1 and E2, two electric fields will be there. So here there are any chances of electric field will be equal to 0? No chances, because always if you are finding the electric field intensity at this point, then I can say E net will be equal to E1 plus E2, always the sum. Okay, but if you are taking the position will be here, due to plus q electric fields are away, due to plus 9q electric fields are away. So here also we have E1 and E2. So total electric field is always equal to sum of these two. If you are adding any two quantities, if two quantities are equal, suppose you assume E1 equal to 2, E2 is equal to 2. So here it is 2 plus 2, 4 will come. Here it is 2 plus 2, 4 will come. But here it is 2 minus 2, 0 will come. So the only point which is always have an equilibrium position for electric field intensity is always the middle position, which means this is exactly same as Coulomb's law. Okay, so in Coulomb's law the equilibrium position of the third charges has to be placed in between the two charges to have an equilibrium. The same case, equilibrium position of the two charges, similar charges, will always lies in between the two charges. Okay, this is a concept of similar charges. Hope you understood. Now we'll move to, this is like the first concept of similar charges. Now we'll move to the next concept. The second part is called dissimilar charges. So second part I am writing here. Second part is dissimilar charges. Dissimilar charges. So dissimilar charges is again same as this one. So the similar charges, as I told before, similar charges, the equilibrium position of the third charge in between the two charges. In case of electric field intensity, the equilibrium position is always in between the two charges. Here also in between, here also in between. So there is no confusion, no difference at all. If there is a difference, only the confusions will generate. So there is no confusions because both cases it is similar. That's all. Here also it is similar. If it is plus q and 9q cases, if you have taking, we'll take plus q and minus 9q if you are taking. So as I told before, two force should be opposite, then only equilibrium will come. Here we'll see what are the two electric field which are acting in opposite directions. We'll take the leftmost point. Plus q will give an electric field away from that one. So this I am giving as E1. Minus 9q will take electric field towards that one. So it is E2. So this is the point where electric field intensity will be equal to 0, similar to this one. Dissimilar charges in Coulomb's law. So here there is a possibility E net will be equal to 0 because E1 minus E2 may equal to 0. There is a possibility. So E net will be equal to 0 like this. So here also we know x quantities. This is a shortcut methods. This is a shortcut methods we applied to find out the equilibrium position for Coulomb's law. X and x, if it is dissimilar charges, then the formula q low minus q root of ql divided by qh minus ql, denominator randume root, then into L. When come to here, root of ql divided by root of qh plus ql, the same formula is applicable for electric field intensity. This is a beauty of this chapter because there is nothing different. That's what I told in the first session of this video of electric field. If you have learned Coulomb's law thoroughly, then electric field intensity is also easy because whatever you have learned in Coulomb's law, the same thing is going to applicable will be here. Here the distance, x distance, here I told here this x meter away from the lowest charge. So here x. So it is a similar charges. So the position of electric field intensity is equal to 0 at x meter away. What is the value of x? Similar to this one. And in case of a dissimilar charges, electric field intensity will be equal to 0 at a position left of lowest charge. So which means it is x meter away. What is the value of x? If it is dissimilar charges, then value of x will be equal to root of ql divided by root of qh minus root of ql into L. So which means, as a summary, the Coulomb's law equilibrium positions for same charges, for different charges, we have a shortcut formula. You know how it is done. How will come to this equilibrium position in the previous session of the video, and also there also I have told these two shortcut methods also. Remember the shortcut method, it will save a lot of your time while you are writing the examinations. The same concept as such duplicately applied on the area of electric field intensity is just dicta copy. There is no difference. Whatever you are learning in Coulomb's law, you can able to apply in electric field intensity topic also. Hope you clear with this equilibrium position of electric field intensity for similar charges, for dissimilar charges. This is, I just brush it up again what you have learned in Coulomb's law. Okay.